All right, so now we are going to solve some absolute value equations. And in the key attributes section, we talked about finding x-intercepts. And so in that case, we were solving some absolute value equations. And we also saw that in each case, we had different types of solutions. So in the case where the absolute value had the vertex on the x-axis, we only had this one x-intercept. In another case, we saw if it was moved maybe down a little bit, we could have two x-intercepts. And in another case, we saw if, say, it was just moved up, we could have zero x-intercepts, meaning it never crosses the x-axis. And so that's what's going to happen in each of these equations. We could have no solution. We could have one solution. Or we could have two solutions. And so when we run into these different cases, it's always nice to have this picture thinking about what's actually happening. And so the other thing I want to mention is if I were to tell you absolute value of x is 3, this would be a situation with two solutions. Because remember, absolute value measures distance from 0. So if I tell you the distance of some number x from 0 is 3, it could be 3 or -3. Both of those numbers have a distance of 3 from 0. And so that's how we solve equations, is whatever is inside these bars, we take that and we set it equal to the positive version of this number and the negative. And so you write it twice without the bars, no bars in this second step here, and then set it equal to the positive and negative. The other thing is if I tell you something like absolute value of equals -3, immediately you can tell me there is no solution. You can't ever have absolute value equal to a negative number. Okay, this measures distance, and distance cannot be negative. So watch out for those cases. And so in the case of number 1, it says absolute value equals 8. So whatever is in this absolute value, this x minus 6, I'm going to write it twice, and I'm not going to write it with the bars. I'm going to set it equal to the positive 8 and the negative 8. I have two linear equations to solve. So I add 6, and I get x equals 14, and x equals -2. Those are my two solutions. Okay, on number 2, we're not ready to write our two equations like we were in number 1. Number 1, the only thing on the left were these absolute value bars. In the case of number 2, we have something sitting outside the absolute value bars, so you always need to isolate these bars first. So if there's anything outside of the bars, get rid of it. This 5 is being multiplied by the absolute value bars, and so to get rid of it, we divide by 5. And these bars, treat them like prison. Nothing interacts with that n plus 10 because it's protected by the bars. And so we divide by the 5, and we end up with absolute value, and then 10 divided by 5 is 2. Okay, the bars haven't gone away yet. And so now we're back to the situation we were in number 1. We're ready to set what's inside the bars equal to the positive and equal to the negative. Okay, notice the bars are gone. That's why we have this negative case over here. And so on this side, I have n equals negative 8. On this side, I have n equals negative 12. Now you can have negative solutions. You just can't have an absolute value equal to a negative. This right here, bars, cannot equal negative. And so the case where we're having like this negative 12 and negative 8, those are like your x-intercepts. So that just means our function is looking like this, 2 negative x-intercepts. Okay, on number 3, the bars are already isolated, so we are ready to set this negative 9x equal to positive 63 and negative 63. Divide by this negative 9, and we get x equals negative 7 and positive 7. And so in this case, we have a symmetrical solution. And that happens when you have nothing outside the bars, nothing being added, no translations or anything. You have the same number, positive and negative. That is not always the case, as we see in number 1 and 2. Okay. On number 4, here's our absolute value, but we are not ready to take the bars off just yet because we have this 5. This means divided by 5, so to get rid of it, we need to multiply both sides by 5. That's the inverse operation. Leaving me with 3v minus 2 in the bars still equal to 25. Okay, now we are ready to set this 3v minus 2 equal to the positive 25 and equal to the negative 25. Oops. (3v minus 2 equals the negative 25. Okay, we had to write it twice. Equal to the positive version of this and the negative version. Okay, so first we have to add 2. Leaving us with 3v on the left, 27 on the right, then divide. Always take care of what's not attached first. So in this case, v equals 9. Negative 25 plus 2 is negative 23. And you can leave your answer in fraction form. Fractions are better. Just simplify them all the way. Negative 23 thirds. Okay, on number 4, here's, I'm going to zoom in. Here's our bars. And so we have to get rid of the 2 and the 4 first. Get rid of the 2 first, because it's not attached to the bars. And then divide by the 4. Still have the bars. Okay, now we are ready to set what's inside the bars, which is just x, equal to the positive 7. I always put it or the negative 7. And in this case, we were actually done when we did that because x was the only thing. And so these are our final solutions. Symmetrical once again. All right, so number 6. First you have to subtract 2. And this is where I stop. I have absolute value. Once you isolate absolute value, if you have a negative number over here and absolute value here, stop. That's a no solution case. That is not the same as the cases we've written. Here I had absolute value equal to a positive number, and then I wrote my negative case. Here I have absolute value equal to a negative number, so I stop and say no solution. If I picture what this is looking like on a graph, this left side is our parent function plus 2. So that means it has been moved up 2. And so it is looking just like that. And we're asking, when does it ever equal -8? Which is way down here. 1, 2, 3, 4. So on a graph, if I were to graph the left and the right side, it would look just like this, giving me no solution.